Okay, it's problem number five, and we just went through four problems, and I hope you realize when I went through those four problems, I kind of thuggishly and slowly went through the rational root theorem, and then I kind of sluggishly and slowly went through Euler's method. We're doing the same exact problem, and how slow and tedious it was. And I'm thinking to myself is that when a computer does it does it incredibly quickly. But what's behind this is that the people that write code know an awful lot of numerical algorithms to do the problems. So what I want to do is I want to launch Sage, which is a computer algebra system. It's a open source, so it's free to use. It's also, you can look at the code too. I did not look at the code for this problem, by the way, but I got to launch it. I don't know what algorithms they're using to solve it. Now, my suspicion is they know about the ones we're discussing here. There's no magic here. They've been around, all right? And the people coding, typically people coding in this area, are quite bright, all right? Typically mathematicians at the PhD level. Not always, though, by the way. Some of them might be high school students that are just incredibly good at coding and understanding mathematics, all right? But let me reset. I'm going to get a clean slate. At least a clean slate as a picture goes. And I'm going to reset, which gives me internally a clean slate, like purging the system. I'm going to say x is a variable, and I'll type that in. And then I'm going to define a function, f of x, and that function is, looking at this problem number 5, x to the 4th power minus 22 star x squared minus 12 star x plus 48. All right? And what I'm going to do, I know it's hard to look at this, but I've defined a variable, and now I've assigned f of x to be a function, and that function is x4 minus 22x squared minus 12x plus 48. I'm going to plot it, and I want to see what it looks like to plot. I'm going to plot f of x, and I don't know what's going to happen. Well, I get that picture there. It's not the complete picture. I want to get roots. So what I'm going to do is I'm going to close that. And I think you probably remember me doing this before. I put x min down. I'm going to say typical graph paper, you might do minus 10 on typical graph paper. And x max, you might go to 10. All right, that's way too far. All right, so what I'm going to do now is, it looks like between minus 5 and 5. I'll close this out. And we've done this many times before. So I'm just going to back over this, use my cursor. And give me a second to put a 5 there. Put a graph down. That's a better looking picture. So looking at it, I'm pretty convinced looking at that picture that whatever the root is, it looks like it could be minus 4. It could be minus 2. The other ones, I'll be honest with you, I have a tough time with it. I mean, it's, 1 point something. And I'm going to say, maybe 4 point something. All right, now again, I could get a better approximation. But what I want to do is I want to test this out. I want to see what f of minus 4 is. Certainly a rational number, right? And it's 0, so that's true. Then I'm going to do f of minus 2. That's also 0. All right, now I'm gonna try the other one. I'm going to do f of, I don't know, that looks about 1.25. Who knows? Maybe it's right. Nah, that's not right. All right, so I'm pretty off there, aren't I? Let's see, that's 2, 1. Yeah, it's pretty far off, isn't it? I don't know if I ever get that one by guessing on it. So what I'm going to do is I'm going to say solve, S-O-L-V-E, f of x. I want the root of it, and I'm trying to solve for x. Now, you might be shocked by the volume of output here. Oh, no, it's not a big volume of output. But you know what? There's a good reason I couldn't get that one. There's no way I would have stumbled on that one using decimals. So what I want to do is I want to talk about what that number is. All right, let's put this down. So I'm going to put that number down. and I'm going to approximate it. And I said 1.25, and what are they saying? It's really 1.2679, yada, yada, yada. Now, you may be curious about what algorithms they're using to solve this. I don't know. I really don't. All right, now they could be using Euler's method to do it. I don't know. Maybe they are. It's methodical. You could do it. You could code it, right? Are there other things to code? Yeah. If you want, you go to Wikipedia, and you could see they have a formula for fourth-degree polynomial. It's huge, though. It's really complicated. I mean, just even the fact that it's so huge, it's even tough to fit onto a web page. That's how huge it is. But anyway, I bet they looked at various algorithms for solving a fourth-degree polynomial and came up with a good one. Now let me point out the other one over here. By the way, they're going to occur in conjugate pair at this point. It's a real coefficient polynomial. But if you were to guess at this one over here, I still, you're not going to get it. I just don't think you'd ever get it. You would never stumble on it, in my opinion. But I'm going to say it looks about, 4.75. And this is not going to work. Well, let's take a look what it gives me. It's off. It's not zero. That's for sure. You want to say, could you guess again and guess again? Yeah, I could keep guessing, but I want to look at this one over here. I'm going to write that down now. So I just copied it. So I'm going to do f of that number. By the way, I don't know what's going to happen. Maybe Sage is not going to want to do the computation. It doesn't want to do the computation. So what I'm going to do is going to force it to do the computation. And someone says, oh, what number is that? That doesn't look anything like what I expected. I was expecting it 0. That number is essentially 0 to the computer. It's minus 5.68 times 10 to the minus 14th. But there is rounding error. That should actually compute to 0. All right? That should compute to 0. All right? But we found the 4 roots. Who's doing that? Sage is doing the work for us. What algorithm they're using? I don't know. Could you look at the source code and figure it out? Yes, you could. I'm not going to guarantee it, but my suspicion is they're doing something like Euler's method to solve that problem, a fourth-degree polynomial. That's my suspicion, all right? Now, granted, it's a little more complicated than that because if they're using Euler's method, they get a cubic, then they need an algorithm to solve the cubic, and we've discussed those before, all right? I don't think they're using a rational root theorem in any circumstance. I just don't think that. I'm not a coder, so I really don't know for sure. But this is kind of remarkable that this could do it for us so quickly, all right? Why is that? It's methodical in what it's doing. It's really nicely coded. The people coding these things know mathematics and they know computers. And they've really done us a great service by coding this stuff and also sharing it, which is a nice thing they've done. Okay, thank you.